In this lecture, we're going to learn about static methods or static member functions. And these are functions that are attached to the class blueprint itself. Let's look at an example here. We have a class called point, and it has two sections. We have a public section, we have a private section. And in the public section, now we have a static member function. And a function is marked static by putting the static keyword in front of the function declaration here. So the getPointCount function or member function is a static method now, and it doesn't belong to any class object. It's going to be affiliated with the class blueprint itself. And this is going to have one consequence, which is really big. Static member functions don't have access to member variables of class objects. Because try to think about it. If the member function is attached or associated with the class blueprint, and we can literally have thousands of class objects, which member variable should the member function access if it belongs to the blueprint? So the compiler solved this problem, and So the compiler is going to see this problem, and it is going to stop you to do any kind of access to the member variables from a static member function. But a static member function can have access to static member variables. So for example, if we look at our static member variable here, which is pointCount here, we can return it from a static member function, and this is going to work without a problem. If you want to have access to member variables from a static member function, what you can do is pass the object as a parameter to the member function. Then inside the member function, you will be able to use the dot notation to access member variables, but you will have to go through the object name like we are doing here. And this is really all you need to know. Another thing you can see here is that we are able to access private member variables of this object. And the reason is because we are inside a point object. If we try to do this from the outside of the class, we're going to get a compiler error. And I am going to show you an example in a minute when we hit Visual Studio Code. Now that you know this, we're going to play with this a little more in Visual Studio Code. Okay, here we are in our working folder. The current project is static member functions. We're going to grab our template files like we always do. We're going to put them in place, and we are going to open this in Visual Studio Code by dragging and dropping here. Okay, we have the folder here. Let's open the main CPP file, and we're going to put in a point class that we're going to use to play with these things here. So let's create a header file for that. We're going to say point.h, and we're going to create a CPP file, point.cpp. Let's do this. I am going to head over to the header file and put in my class for point. It is nothing you haven't seen now. We have a point class. It has two sections, a public one and a private one. And we have our member variables, and we have a static member variable here. After this, we're going to head in the CPP file and put in our implementation. And again, it is nothing you haven't seen so far. And we can close the left sidebar here because we don't need this anymore. Okay, now we have a static member variable. We want to set up a static member function to the point class here. So the way we do that, we're going to use the getPointCount function here. You mark it static by adding the static keyword in front of the function signature here. And at the moment we do this, you see that we have a problem. The const keyword can't really be applied to a static member function. And the reason is the static member function doesn't have access to the member variables. So what is the meaning of the const keyword here, whose purpose is to protect you from changing the member variables of a class? So this doesn't really make sense. We're going to take this out. And our static member function is going to be working now. If we head over in the main CPP file, we can take out what we don't need here, and we're going to include the point class. Let's do that. And we can go down here and call the static member function before even a point object is created. We can print that out. For example, we can say pointCount, and we're going to say getPointCount. You see that we have access to this through the colon syntax here, and we can print that out. Okay, so let's try and build this with GCC. Let's see what we get. And we have a compiler error. Undefined reference to point count. The problem is we didn't initialize our point static member variable. So what we can do here is mark it in line. We can do that. And this is going to allow us to initialize this from the class declaration. And this is going to work, I guess. So let's do that. We're going to build again. Okay, now you see the build is good. We can clear and run Rooster. We should get a 0. Okay, point count is 0. But if we go down in the main CPP file and say point P1, for example, and print the point count again, this should go up to 1 because anytime we create an object, we're going to increment the point count as we have seen before. Let's show you this in case you have forgotten. We are incrementing m point count in our constructor here, and this is the constructor that is going to be doing the incrementation here alone. No other constructor is going to do this because other constructors are going to delegate the work to this constructor that takes 2 parameters here. You see, the one param constructor is going to delegate to that, the no param constructor is going to delegate to that, and the copy constructor is not delegating to that guy. It is initializing the x member variable alone, but we can delegate. So let's do that. We're going to say point, and we're going to say point mx, and we're going to say point my. This is going to do. This is going to initialize our little guy with the data coming from the source point, but we're going to be delegating to the 2 parameter constructor on top here. So I am glad I had a chance to show you this, and let's use, we are using parentheses here, but if you want, you can use curly braces in the place of this parenthesis here. So now this thing is working. If we go to build, we're going to see that the build is good. Now we should get a point count of 1, and you see the point count is 1. Again, we are able to use this syntax because the getPointCount method is now static inside the point class. If we take out the static keyword here, we're going to get a compiler error if we're trying to do something like this. Visual Studio Code should give us a few squiggly lines, and you see we have them. And if we're trying to build, we're going to be told we can't call this member function like this. So what does the error say? You can call member function without an object. So if you are doing things like this, so if the member function is not static, you can't really call it like we are doing here. If you want to call it, you need to go through an object name. And for example, we can go down to the second guy here and say P1, get point count. This is going to work because the member function is public. Let's build. You really need to know all these little nuances about how member functions work in C++. So we're going to run Rooster. We're going to see that the point count is 1, and this is working, but the syntax on top only works if the member function is static. Let's go back and make it static again. We're going to make that static. And the next thing I want you to see is that static member functions don't have access to the member variables of the class, or of the class object, I should be specific. Let's set up a function and show you that. We're going to say void printful, and we're not going to take anything in. And inside the body of this function, we're going to print the information about the point, nothing special here. And if we try to build, let's do that. We're going to use GCC. You're going to see that we have an error. And what is the problem here? We are trying to go through an object. Let's take out the P because we don't have that here. And we're going to do this. You're going to see that the build is going to be good. Okay, so the function is here and it is working. We can use it in the main CPP file. For example, we can say P1 printful, and it is going to work. We can comment out everything else we have here. Let's do that. And we're going to build. We should see information about P1 printed out, and it's just going to have zeros in for X and Y because we use the default constructor to build this object here. If we run Rooster, we're going to see that X is 0 and Y is 0. Okay, so this is working. But the moment you mark this function as static, let's try to do that. We're going to get a compiler error, and you see we have a few squiggly lines because we are not allowed to access member variables of objects from a static member function. And the reason is the member function is now attached to the class blueprint itself. It's not attached to any class object, and you wouldn't really know whose object's member variable you're going to access through this member function here because this member function doesn't belong to any object. So we're going to get a compiler error here. Let's build and show you the compiler error and see what GCC is saying here. We're going to have .my in static member function, and this is not allowed. They are going to tell you this here. And we're going to also see invalid use of member in static member function. So this is invalid. This is not allowed. If you do this, you're going to get a compiler error. So what do you do if you really want to print the information about a point object through a static member function? Well, you can pass your point object as a parameter to the function. For example, we can go in here and say const point p. Let's make this a reference because we don't want copies. And then we're going to say pmx. This is going to work. And then we're going to say pmy because we are going through an object name. This is going to work now. Now it is super clear whose member variables we are accessing. And notice that this is working because the printf function is part of the class point here. And notice this is working. We are able to access member variables of this object because we are inside the class point. If we try to do this from the outside, this is not going to work because we're not allowed to access private member variables of an object from the outside. But let's try and build and show you that this is working now. We don't have the problem we had before. And let's see, in main, we are calling without a parameter. That's why we have this compiler error. So we can pass p1 here, and this is going to work. Let's build, and we are going to build successfully. As you see here, we can clear this and run Rooster, and we see that we have the information here. Point count is 0. Okay, so if we run Rooster now, we're going to see that the point information is shown here, and this is what we want. X is 0, Y is 0, and this is what we expect. Let's try and change this to, let's say, 6 and 7, and really make sure this is working. So we're going to build with GCC. The build is good. We can clear and run Rooster. We're going to see that we have our member variables here, and this is really cool. So now you should note that with a static member function, you don't have access to the member variables of the class. You can't do that because a static member function is really not tied to any object. Another thing you can't do, as we have seen before, is mark a static member function as const. Because the const keyword here is going to protect you from changing the member variables of the object. But remember, a static member function doesn't have access to the member variables in the first place. So this is really confusing and weird, and it doesn't make sense. So the compiler is going to stop you from doing this. And if you do this, you're going to get a compiler error. Let's build again and show you this. Okay, we have a compiler error, build finished with errors. And if you go on top, you're going to see the problem. Static member function, our function here, cannot have CV qualifier. So it is the const qualifier because the static member function can't be const because it doesn't really make sense. And we have the same problem here. So you should note that if your member function is static, you can't make it const because it doesn't make sense. Let's take this out, and we're going to build again and make sure that our thing is working, and it is working. And this is really all I had to share in this lecture, showing you how you can use static member functions. Use them if your function isn't really tied to any class object and you want it to belong or be tied to the class blueprint itself. And if your member function is static, it's not going to have any access to member variables of the class. You can't have this pointer. If you use that, you're going to get a compiler error. You can't access the member variables, and you can't really do anything that directly affects an object, because the static member function doesn't have an idea of the object in which it is operating on. It is operating in the context of the class blueprint itself. Okay, so this is really all for this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about nested classes. Go ahead and finish up here and meet me there.